Okay, for 5-7, they want us to solve the systems algebraically and then graph. So let's solve. So the first one is x plus y equals 3. And I'm just going to, let's see, okay, so x equals 3y minus 5. So we can use substitution. We'll take 3y minus 5 and substitute in for x. So we get 3y minus 5 plus y equals 3. Remember, I'm taking this right here, right, and I'm putting it in, substituting it in for x. Okay, so 3y and y is 4y minus 5 equals 3. 4y equals, add 5 to both sides, 8. Y equals 2. And then we know that x equals 3y minus 5. So x equals 3 times 2 minus 5. X equals 6 minus 5, which is 1. So the solution is 1, 2, the ordered pair. Okay, now let's graph. So x plus y equals 3. So one of the points would be 1, 2, right? I'm just picking points. If x is 1, y is 2, right? 1, 2, and then another point would be 2, 1, right? Because 2 plus 1 is 3. So 2, 1, and then we could draw our line. And again, yours will look better because it's with a straight edge. And then the second equation, x equals 3y minus 5. If y is 0, we get x is negative 5. So if y is 0, x is negative 5. So this is going by, actually my graph. Let's go by ones. Let's make this 5, right? And this negative 5 for this first graph. I was going by ones on the graph paper. Okay, and then so if y is 0, x is negative 5. 1, 2, 3, 4, 5. There's, the x-intercept is negative 5, right? So the x-intercept is negative 5. So there's that point. And then if, let's see, if x is 0, let's substitute that in. And again, I'm doing this equation now. If x is 0, 0 equals 3y minus 5. So 5 equals 3y. That's not a very nice one. And then y equals 5/3. That's not a nice graph. So let's take another approach. Let's rearrange this into slope-intercept form, right? So we get x plus 5 equals 3y, right? And I'm going to rewrite that as 3y equals x plus 5. And then y equals 1/3 x plus 5/3. Again, not wonderful, but not so bad. So the y-intercept is 5/3, right? So that's almost 2. That's here, right? And then it's up 1 over 3, right? Up 1. That would bring me to here. Over 3, 1, 2, 3 is here. And we draw a line through it, right? There's our line through it. And yes, we do get that as our intersection point. Okay, let's do B. Let's clear this. Okay, so for B, we have x minus y equals negative 5, and y equals negative 2x minus 4. So I'm going to take this and substitute it in here. So I get x minus this whole thing, negative 2x minus 4, equals negative 5. So now we'll distribute the negative in. So I get x plus 2x plus 4 equals negative 5. X plus 2x is 3x plus 4 equals negative 5. 3x equals negative 9. X equals negative 3. Then we'll substitute it in. Y equals negative 2x minus 4. Put in the negative 3, negative 2 times negative 3 minus 4. So y equals 6 minus 4. Y equals 2. So negative 3, 2 is the solution. Again, we're doing this one, right? So let's graph. I'll graph the second one first. Y equals negative 2x minus 4. That one has a y-intercept of negative 4. Again, I'm using this as, I'm going by ones, right? Okay. Y-intercept of negative 4, 1, 2, 3, 4, and a slope of negative 2, so up 2 over 1, right? Up 2 over 1, right? So there's an up 2 over 1, right? If I want to keep going, right? Okay, so there's my graph for the second one, because it was in slope-intercept form, much easier to do. And then let's put the top one in slope-intercept form. So x minus y equals negative 5. So negative y equals negative x minus 5. Let's draw this line here. And then multiply by negative 1, y equals x plus 5. So the y-intercept is 5. 1, 2, 3, 4, 5. And the slope is 1, right? So it goes down like this, right? And right here is the solution, which is at negative 3, 2, which coincides with us solving it as a system of equations algebraically.